Hello, Richard here on the RPS project. Okay, so sorry about the noise, there's somebody trimming their hedge out there. Here you go. Okay, last time on my LED light project saw me blinding myself with some very bright green LED. Wasn't going very well, wasn't sure why. And I started to actually look at the circuit thinking, well, what have I done wrong? So what I need to do really is take a big step back, look at what it is that I want to achieve, what circuit I'm going to need to try and make that work, and then do some testing and calculations to find out if it can actually work, if I can do what I want to do. So that's what I'm going to do today. I'm going to actually have a look at the LEDs themselves. I'm going to see what current they need, what voltage they need, what is required to make them operate, and then start looking at whether or not my idea of powering them and making this circuit work is actually going to be correct, whether it's going to be feasible, whether it's something that's just going to never work, it's always going to be causing me problems. So that's what I'm going to do today. I'm going to have a look at that circuit, have a look at the proper circuit that I've now worked out, look at the LEDs, and have some fun with blinding myself again, I suppose. So here goes. After I finish my brew. Okay, here we are with a bit of circuit, some I've set up for testing these LEDs, which are under here, which I put under these. It's like a heavy tissue sort of paper stuff, because when they're on fully they are very, very bright. Now the idea is I would do something from this, which is a 555 circuit, and basically this one has got a pot here that I can change the duty cycle to give me an output. Now this is a circuit that I've seen many times on the internet. I've seen a few people on YouTube use this circuit to power some LEDs. The thing is, though, they were powering up I suppose ordinary low powered LEDs, not the big more powerful LEDs that I've got here, which aren't that powerful really, but certainly a lot more than your standard LED you might find. And then take the output into a transistor, which is going to turn it on and off, and turn on the LED. And using the pot, I can control how much brightness I've got. The only thing is that some of these values aren't quite. This area, this part of the circuit is fine. That works as I would expect it to, and my output is as I would expect it to. Now the part I've got to start looking at is the transistor, which involves the transistor itself, what voltage what current I want coming in, what resistance. This effectively like a voltage divider there. I'm using a diode to give me a voltage of about 0.7 on the base. It does work. It's a workable circuit. I've used it on very low powered LEDs. Of course, not really sure it's going to work on this circuit. So what am I hoping to get on the output? Now I've got two considerations here. The first one is basically have my output and having each LED powered through a different transistor. Don't know if that'll work. I've sort of tried that and ended up with a very odd result. I've got a lot of flickering. They would sometimes not come on, or they would come on so bright it was almost blinding. Well, not really have the control I would be expecting from the 555, so not really sure what I was doing wrong there. Again, it comes down to understanding circuits better and doing some testing beforehand. So to test it out a little bit better, I thought what I'd do is like this circuit, basically have the 3 LEDs and put it through one transistor, because then all the current's going to go through the transistor. All I've got to do is provide enough base current that the transistor's turned on, and it'll draw the current required to go through this. Only, what are these going to require, these 3 LEDs? Are they going to be able to, is this transistor going to be able to provide the switch, as it were, for these 3? And do I have enough voltage? Can it provide enough current? Is it just going to smoke? So that's the other thing. I've calculated this, and the BC337 has got a maximum current of 800 milliamps, and I calculated that the total current that's going to come in for these 3 LEDs is 816 milliamps. So basically, wrong transistor. I need to find a better transistor. Now, I am using a better transistor. It's called ZTX651. It's got a 2 amp capability, and seems to work quite well. So that's what I'm going to test first. What I'm going to do is I'm going to have a variable voltage for the base, which is this meter is going to show the current for that. This has got 12 volts coming into it for the LED. So I'm going to see, as I increase this voltage, which allows the current to increase on the base, I'll see what current is going to be required to light up the LED to its fullest extent, so I can get an idea of what is required to make these things work. So I've got the first one connected up. I've got all 3. I just got the power for the red one, I think, to start off with. We'll go red, green and blue. see what they require to work. So let's turn it on and start having a look at what's going to happen when I turn up the voltage. Obviously 12 volts are on, but I've got nothing on the base at the moment, so let's turn the base on. There we go. I've got a red LED. It's not so bright, so let's just use one filter for the moment. And see, that is on. That's a nice red. I don't know if you can see that. It is actually on, the red. Now, just in case you're wondering, this power supply box over here is basically an old computer power supply that I've again seen people converting into their own little bench power supplies. The variable bit here, I can't quite see it because I've not quite got it in shock, but from this camera angle I wanted you to see the meters more than the voltage. Basically there's a little LM338 in there, which is effectively the slightly better powered LM317. 317 does 1.1 amps. The 338 can do up to 3 amps, I think. So it's a 338, I suppose. So it can certainly provide the current needed to make this circuit work. Now, as you can see, red LED, I've got 0.35 milliamps, and this is set to the 10 amp range on here. So I've actually shown us 80 milliamps going into the LED at the moment. 1.2 volts. The circuit here I'm using is a basic. I suppose it's a bit like this one, only each one I'm disconnecting out, so I've only got one LED in at any one time. But instead of using a 555, all I'm doing is I've got 2k resistor, 12 volts, 2k resistor, and then straight into the base. And it's not a BC337, it's a ZTX651. Let's write that down. ZTX651. I really ought to get a pen, shouldn't I? Instead of a pencil, can't see that. ZTX651. So that's on. Now let's turn up the voltage on the base and increase the current into that base and see what is required to have this LED on at full power. It will get to a point where it won't draw any more current because it's on maximum. So going up, I'm on 2.3, 2.4 volts, 2.3 volts, and they're still both going up. 3, I'm now on 3.94 volts, and I seem to have hit a ceiling on the LED. Oh, here, this isn't going up anymore. It's about 300 milliamps, and even though I turn the voltage up to say 2 milliamps on the base, that is still 3 milliamps. So I actually can bring that back down to find that point where it's about, I suppose, 4.4 volts. 4.4 volts through a 2k resistance onto the base, giving me 1.8 milliamps on the base, gives me 300 milliamps through the LED. So that's what it's going to require. I've already made a note of it over here. So let's turn that down and do the next one. So let's disconnect the red. That's the green one. So I want the, so that's the red. Green one. So I'll turn on the green LED this time. So 12 volts on, and turn on the base for current. Right, okay, so I'm going to start turning this up. I see it's on because 1.24 volts should be enough to turn on the transistor. And effectively, I suppose what I'm doing is I'm taking the transistor into saturation, so I get as much power and much current as I can into the LED so it can be fully powered. So 2 volts, 3 volts, and it's still going up. 3. I should be sort of hit ceiling already. I'm at, if I take the base up to 2 milliamps, this is still at 270, and it was at that way before 4 volts. So I'm at 4.7 volts, so I'm going to turn it down, see at the point at which it starts to go down on the here it goes down there. So it's about 3.8 volts. 3.8 volts. And I've got 270 milliamps through that, and the base is 1.5 milliamps. And that's what's needed to basically power the green LED. So that's quite a bit. So let's go and have a look at the blue one. Let's turn that down. Connecting the blue LED. Cover that up. 12 volts on. It's my variable. Blue LED is on. Again, 1.24 volts. Turns the base on. At the moment I've got 0.32 on the base. 60 milliamps running through it. Let's turn it up and see how high I have to go. 3.5 volts. 3.8, 4 volts. Actually, I seem to have hit a ceiling already. So 2 milliamps, 4.8 volts, 260 milliamps. Let's turn that down until it goes down. And I'm at 3.6.5. It's about 3.5 volts, 250 milliamps into the into the LED with 1.38 on the base. So if I add all that up, then effectively what I've got is somewhere in the region of about just under 5 milliamps required on the base to be able to power all 3 LEDs, because I need about 800 milliamps through all 3 to ensure that it's going to light all 3 up, which means that whatever the gain is, it's probably going to be equivalent to the sum of all of the current on the base. So as you can see, I've got like 1.3, 1.8, so 1.45, and the total current through all 3 LEDs is going to be about 800 milliamps. So that's quite a lot. That's why the BC337 was no good, because it would burn out at that point, because that's right at its maximum, whereas the ZTX651 can handle up to 2 amps. So let's turn that down, and let's connect all 3 LEDs up. Let's put them all in. The blue, got the green, and the red. Now, just literally use all 3 of these bits of like filter paper, whatever you want to call it, tracing paper, thick tracing paper. And now I'm going to turn it on with all 3 LEDs connected and see how much it's going to draw. That's the 12 volts on, and that's the base voltage on. Now, as you can see, there you go, they are on. Use a bit more. You can still see that, you can tell that they're on. I'm going to start to turn it up. At the moment, before I start, I've got 0.35 on current on the base. I've got 80 milliamps through the whole circuit. It's 12 volts through the LEDs, but it's only whatever that voltage is, whatever I've got coming, it's 1.24 across the 2K resistor onto the base. And I'm going to turn that base voltage up and see what current is required to make these things work. 2.5 volts. .3 volts. As you can see, I'm already up to 370 milliamps here. 1.3 on the base. Take that up to 4 volts. 1.8 on the base. 520 milliamps through the LEDs. So they're already drawing half an amp. You can see how bright that's getting now, can't you? Let's turn it up. Let's take it to, so I get it up to 5 volts. 5 volts. 2.27 on the base. 600 milliamps through those LEDs. They are getting bright, but it's not hurting it. And I bet you've already noticed that these resistors here are pretty chunky ones. That's because I've calculated that we're at a sort of 2 watt rating for the for these resistors, and they're all what I've done is I put 30 ohms resistance for all 3 LEDs. They're all the same, just to keep things nice and even. But yeah, so they're, I think they're 3 watt LED, 3 watt resistors, sorry. But I felt I needed to go overboard while testing these, because if I just put a 1/4 watt in there, it'd soon be toast. Let's turn up a bit more, so I can get to take up to 6 volts. There we go, 6 volts, 2.75 current on the base, 660 milliamps through the LEDs, and we keep going. 7 volts. I can keep going because, like I say, this transistor is 2 amp rated. 3.21 milliamps on the base, 700 milliamps through the LEDs at 7 volts. These are seriously quite powered, high powered LEDs. Like I say, they're not even what you call really high powered. I mean, they're not like 30 watt or 50 watt LEDs, but they do take a lot of power to make them work. 8 volts, 3.68 volts, 67 current milliamps on the base, 730 milliamps through the LEDs. Let's take this up. This power supply on the variable will only go up to about, I think it's about 9.5 volts, because I didn't want it too high. I've only got a 12 volt into it, and LM338, like the 317, it's got a certain dropout voltage. It's about 1.5 volts, something like that. So I can only go up to about, I think it's 9.9 volts. 9.9 volts, about as much as I'm going to get out of this power supply. Got 4.54 volts. Sorry, that's not 4.54 milliamps of current on the base, and 770 milliamps through the LEDs. So I keep thinking I want to put a BC. I will do. I'll put a BC337 in there in a moment, and you'll see that instantly it'll be toast, because it just can't handle what we're putting into it. So that's about as much as I can get into there. So what I'm going to do is I'm going to take this power that's going through here, through the resistors onto the base, and I'm going to put it directly onto the 12 volts. So I'm going to have a full 12 volts through the LEDs, 12 volts onto the base, but through this 2K resistance, and see what happens. So turn that off, turn that power off, and move these over. So what I should hopefully see now is these 3 LEDs turned on full. Okay, and I can see the current that's going to be on the base there, and total current for the LEDs there. There we go. 5.45 milliamps on the base, 800 milliamps through the LEDs. And now my idea was to have 3 banks of these, but with an ordinary power supply, so like a one of those little switch mode plug top things you're banging everywhere, isn't going to do it, because I would need to have some headroom as well. I'd want to have that 3 times, so I'm talking 2.5-3 amp power supply. I suppose really what I'm going to need is to use something like a buck converter. Sorry, a buck converter, no, a boost converter, that's it. I'm going to need a boost converter to give me the current that I would require to light up 3 banks. Now the other problem here is I'm thinking, well, if I'm needing 800 milliamps through one transistor to like those three, right? And I've got 12 volts to give me the 5.47 milliamps on the base, then the problem I got is the 555 circuit. Now the 555 works in that this voltage, when it's on, is 2/3 of the supply voltage. So that coming out there is only ever going to be 6 volts. And if I'm putting it through a resistor and a diode there, then that's obviously going to reduce the voltage. The voltage on there is only going to be about 0.7 volts at any one time. And the amount of current that this can deal with, I think the output can only deal with about 100 milliamps, which is great because we only want 5.47. So in theory we could say, as long as I can get the output even at 6 volts to give me the 5.47 milliamps on the base, then I should be able to power the 3 LEDs. That's something I will test out and then come back to you and actually show you whether that works or not. But for now, I think this is about as far as I want to go today, because I have managed to learn something. I've learned that I'm going to need a lot of current to power just a single bank of 3 LEDs. Now I could change the LEDs and go for 3 white LEDs rather than 3 rather than the R.G.B, because then I'm talking about this same current requirement for all 3, and I get a much brighter white light. But I did say I was going to put a BC337 in there and see what happens. So let's do that. Let's turn something into toast. Let's find a BC337. There we go. The BC337, if I remember rightly, has got a collector base emitter, collector base in the middle emitter, so I need to put that in correctly. So the collector base emitter, so I need to turn it around and put it in that way. I'm going to turn this on, and I'm expecting that it will be dead in seconds. No, but we have only got 580 milliamps there, so it is working, but not as well as the ZTX was. So I'm wondering if that's going to eventually burn out. It is working. Obviously these aren't going to be as bright as they were before, because we're only on half a milliamp rather than 800 milliamps. You know, that's working. It's not burnt out, but I expect it's not very healthy. I'm surprised it's working, but there you go. It has worked, but I wouldn't want to give any guarantees on how long that'll actually last. So that's creeping up. No, steady. No, it's not going to go on fire for me. See how long it'll take before it actually dies. 600 milliamps. I think it's getting warmer. I think it's going to be toast before too long. Is it going to burn? 640 milliamps. Oh, there you go, it dropped down. Now it's getting unstable. The base is starting to go. here it goes, and the magic smoke is escaping. That is dying because it just, and the LEDs are flickering. There we go. It is it's toast basically, because it cannot handle the current that these 3 LEDs require. So let's turn it off. Yeah, there you go. So I suppose back to the drawing board, have another look at this. I know what the LEDs are requiring now, and it's a case of how can I power them effectively to keep them on and not destroy anything. Yeah, the smell, it's pretty awful here. Better get tidied up. Okay, catch you next time.